This video discusses the solution to Module 5, Lab 5-9. We will discuss concepts you need to know, including functions and the use of floor division in Python, and then we'll discuss the solution to Lab 5-9. First thing you need to know is about functions. Functions are another way of saving time like cutting and pasting code. They're used when you need to repeat some process or functionality in your program. All of this leads to reduced work for programmers and something that is very best practice, which is reuse of code. So, as you may know by now, a function is a block of code, and that function will only run when your program calls it. You can pass data to functions, and when you do that, that data is known as a parameter. And this data, when you pass it, is used to help the function to do its work or to do its job. And functions can also return data to the code that's calling it or its caller. So here we are showing how functions can be defined in your program. We use the def keyword to tell the Python interpreter that the code that follows is a function. Notice how all the code that's included in the function must be indented. So here we have a function called myFunction, and it prints hello world. To call this function, you would use the function name followed by the parentheses. Now notice these parentheses are empty because we're not passing any value to this function, we're just calling it. So a function is a block of code. It only runs when your program calls it, and you can pass data known as arguments into that function to help it do its work. The arguments are listed after the function name included inside the parentheses, and you can add as many arguments as you need to help that function do its job. But those arguments must be separated by a comma. Here's an example of that. So we have a function called printPay. Now this D should be lowercase, so we have a typo here. So this function takes in two arguments. They're called parameters inside the function, but when they're passed, they're called arguments. So it's taking in hours and rate, and it's calculating pay, and then it prints pay. We can call this function by simply calling it and putting the values that we want it to use, or the arguments in this case, inside the parentheses. These could be variables, but here I'm just using two integers. So here's an example of this program when it runs. So this is a fairly nonsensical example because the rate would typically not be $4 an hour. That's not minimum wage. But let's say we have a function called printPay. We pass hours and rate to it, and then pay is equal to hours times rate, and we print it, and here's the answer here. So functions, as we've stated, can return values, and we use the return statement for a function to return a value. So here we have another function called calculatePay. It takes in hours and the rate, and the pay is calculated by multiplying hours times the rate, and it's going to return that pay that it calculated to its caller. Now notice, the names don't have to be the same here. This is just positional. So whatever the first one is that's passed to this function will go in what we're calling it here. Whatever the second value is that's passed to this function will go in what's being called here. And notice, we're returning a value called pay, but it does not have to have the name pay in the caller. So let's walk through the example. So here's our function, and here's how we're calling our pay. We're saying some variable called pay amount is going to equal the return value from calling this function calculate pay and passing the value 20 and 25. Then we're going to print pay rate is pay amount, which is the value that we get from what was returned from the function. So here's what this program would look like when we run it. Here's our function, calculate pay. Here's the parameters that it accepts. And remember, these values, when we're in the function, are called parameters. Here's the caller to the function, and there's a variable called pay amount that is going to get the value that's returned from when we call the function. Here we call the function with our two arguments that we pass, and then we print pay amount is pay amount here. Pay is pay amount. And here's what this program would look like when we run it. All right. Let's talk a little bit about floor division in Python, because that's something else we need to understand to solve Lab 5-19. So in Python, there's a double slash operator that works as floor division, and this simply means it will cut off the fractional part of the number. And that's going to be very important for calculating the number of coins in the integer that we're going to pass to the program in Lab 5-19. So here we have a program where we're going to show the use of this floor division or the double slash in Python. So if we say print 5//2, notice not 2.5, but the value 2 will print, because this double slash is going to truncate or eliminate the fractional portion of this number. In this case, it would be 2.5. Okay, so here we have the solution to Lab 5-19. It's going to use functions, and we're going to have a function here that's going to help us determine the number of coins that are required to solve the lab. So let's just review what we're supposed to do in this lab. We're to write a program with total change amount as an integer input, and this program will output the change using the fewest coins, 1 coin per line. The coin types are dollars, quarters, dimes, nickels, and pennies. And we have to use singular or plural names as appropriate. So 1 penny versus 2 pennies. Notice this would be the plural value here. So and we're given an example of what our output is supposed to look like. So if the input to this program is 45, the fewest number of coins per the direction here would be translated for this number into 1 quarter and 2 dimes. Not 4 nickels, but 1 quarter and 2 dimes would be the fewest number of coins. So we're going to use a function to help us to solve this lab. And function is going to help us to calculate the exact change, taking in that value that's going to be provided to us from the user. So let's just look at the structure of the program. So we have the function listed first. This way, when we call the program, it's already been interpreted or scanned into our program by the Python interpreter. So if we were to call the function before we declared it up here, we would get an error because the Python interpreter will not have gone through this code and loaded it into memory. So it wouldn't know what this function was. So now here's our code that helps us to set up our main function, which is just really the entry point into the program. So this is a standard statement that we have when we're using functions. This starts the program and allows us to call the function. So the first thing we do here is we input the total change amount as an integer. It's this number that we're going to try to determine the fewest number of coins for in our function up here. So we're going to get this value, we're going to make it an integer. Okay, and we're going to use this input statement. So the input statement processes first, displays enter the total change amount as an integer. Then this value is converted to an integer and then put into this variable. So a good way of working on these is either thinking how this works is right to left, doing what's inside of the parentheses first. Then, as we did in one of our examples earlier, we're going to call this function exact change using this input value that we just got from our user. And we're going to take the return value from this function, and in this particular case, several values will be returned, and here they are. Now they're going to be returned in the order that they're listed here. So the names don't have to be the same because remember I said it's the order that counts, the position that counts. So in the return statement from the function, notice num dollars will go here, num quarters will go here, num dimes will go here. These names did not have to be the same. They are coincidentally, but they would be aligned positionally. So we call our function here, and then we go inside the function. Now we're passing this information, the total integer, this change amount integer that we got here, we're passing it to the function, and then the function starts working with this particular number. So it takes the user total that it got and it puts it in a variable called money total that it's going to use to do its work. So first thing we want to do is get the number of dollars. We're going to take money total and divide it using floor division by 100. So this will give us the whole number of dollars that we have. Then what we're going to do is take that money total number and we're going to subtract from it the number of dollars times 100. So that just gives us, in this, let's say we're using 345 as an example. If we divided this here by floor division, we would get 3, the number of dollars. We're going to multiply that times 100, so it'll be 300, and then what will be left is the remaining change that we have to calculate the rest of these values for. So once we subtract out the number of dollars times 100, then we'll have what's left for the quarters, and we divide that by 25, floor division. Then we're going to subtract that amount, multiply it times 25, and that will be the money total here. And then we just keep cascading this down. So let's see how this program would look when and then of course we return those values to the program. So let's see how this program would look when we run it. So I'm using a program I like to use, a free program online called Python Anywhere. And here's our function that we've declared. And here is in the program where we will do some additional logic. If the input value is less than or equal to 0, we'll print there is no change. If the number of dollars are greater than 0 when we're printing our calculated value, this will help us to determine if we say dollars, dollar or dollars, quarter or quarters. This is the logic that we use to determine if it's a plural amount as required in SciBooks. Okay, so let's just run this program. So we'll enter the change amount as an integer. So let's say we write 346. Enter that as an amount. That will come out with $3, 1 quarter, 2 dimes, and 1 penny. So notice here in the logic, if we enter 346, we're going to capture that here, and we're going to pass it to the program here, and we call the exact change function right here. And in this particular case, just to run through the first part of it, money total will equal user total. In this case, that's going to be equal to, I'm putting a comment here, 346. So when we say num dollar equals money total divided by 100, in this particular case, num dollars will equal 3. But 3 isn't going to help us to get to our final value. So we multiply it times 100. So now num dollars equals 300. And so money total will equal num dollars. Well, you'll subtract this $300 from the money total. So now money total is going to equal 46. So to continue along, num quarters will equal money total divided by 25 using floor division. So since we're using floor division, num quarters will equal 1. It can't equal 2 or 1.5 or any fractional number because we're using floor division here, so it'll just take the integer. So 46 divided by 25 is like 1.86. But we're using floor division here, so it'll just give us 1. Now let's go to the next line, and we'll see that money total, we're going equals, this minus equals means money total equals itself minus num quarters times 25. So that will equal 46 minus 25, which equals 21. And we just keep doing this down the line. And then when we get here before we print, we look at the number that we have of dollars, quarters, etc. If it's 1, we print quarter or dollar. If it's more than 1, we do the plural version. So carefully inspect the code and walk through these examples yourself, as I've done here, and then you'll see how we used our code and functions and floor division to solve Lab 5-19. As usual, if you have any questions, please feel free to contact me via email and we can discuss this solution in more detail. This is Linda Gaston. I'm your instructor for IT 140. Thank you.